Welcome back. So, again, this phone rang that is not hooked up to a plan. How is this happening? Technology. Woo, woo, woo. So anyway, I went and got my party hat for us to be on our last video, because I'm going to just talk about 20 and make this 3 weeks worth of homework, because 20 is really not enough. You add an acid and a blood base. It neutralizes. You get salt and water. That's basically 20. So I'm going to make this 3 weeks worth of homework and just and make this our last video, hence the party hat. All right, and now I got the phone that absolutely is not hooked up to a plan and shouldn't ring for the rest of this video. All right, so what we were talking about is acids. In general, you can think of as things that put a hydrogen out into the liquid, and that makes it acidic. The more hydrogen, the more acidic. Bases you can think of as things that put a hydroxide, an OH, out, and it makes it basic. Sodium hydroxide is light, it's very, very strong, it's Drano. They can be very caustic. Both of them can cause great damage to living organisms, so they're both dangerous. Now, what's not dangerous? What is neutral? Water is. And let's think about water. What is water made out of? H2O. So imagine here's our Mickey Mouse head, and here's the two ears. If you break it apart, where you have one hydrogen and oxygen together and another hydrogen go off by itself, then you have an acid and a base in exact equal amounts, neutralization. So water is the perfect neutral. It is neither an acid or a base. It is both an acid and a base, but they cancel each other out. Exactly neutral. So water is our example of what is neutral. Let's see what we want to talk about next. Okay, so how is acidity or basidity measured? By the idea of pH. So pH is a math problem. pH is equal to the negative log of the concentration of the hydrogen atoms that is in the solution. So you get to use that log button on your calculator. Yay! That's fun, isn't it? The problems, you just put it in. Let me show you a calculator just in case you don't know how to do it. So for your problems, you'll turn your calculator on. If you're in graph, you get out of that. And so if I was going to do a problem and I had the concentration of I have the concentration of an acid to be, so I'm going to do negative log, see the button log, negative log of the concentration of the acid, and I'm going to say my acid is 1 times 10 to the negative third power. I do 1 second comma is this EE button, that is your times 10, -3, enter, and it tells me that the pH, I don't know if you can see it, is 3. So you just type these in your calculator. You can also get the pOH, which is the concentration of the base part of it. And so the concentration of the base of this one would have, if you took the negative log of it, it would have been 11, because if you add the pH and the pOH together, you get 14. So if something is completely basic, it's 14. If something is completely acidic, it's 1 or less than 1. It's all the way on the other side. And neutral is right in the middle at 7. So the most acidic things have pHs of 1. The most basic is 14. And then as you get closer and closer to that 7, that's where you get those not dangerous pHs. Things like vinegar and things like that. So acidic is pH less than 7. Neutral is 7, and basic is pH greater than 7. So those are some fun little things. It talks in your book about acid rain, about how that can hurt some stuff. So pollution can cause reaction with water and make our rain more acidic than it needs to be. Your book has calculating pH from concentrations using kW. That is more honors problem. If you want to understand it, watch Peterson's Science and he'll explain it to you. Also, the example 6, really for regular chemistry, all you have to be able to do is pH is the negative log of the concentration of the hydrogen atoms. And at my school, they don't really even teach that. So you're getting to learn a little extra at no extra charge. All right, so now I told you that there are different definitions of acids. Because we knew about acids, we knew about vinegar, we knew about acids long before we knew any chemistry at all as people. So one example is called the Arrhenius acids and bases. And this one is that an acid donates a hydrogen atom without its electrons, so it's just a proton. If you had a hydrogen and it lost its electron, all that's left is the proton. And if you have something that can give a proton, like a hydrochloric acid, then it would be an acid. If something can add 2 protons, like sulfuric acid, then it is called diprotic. You can even have things that are triprotic that could give 3 protons. So another way you can have an acid is what's called an organic acid. Vinegar, aspirin, those are organic acids, and they don't just donate a proton. Instead, what I say is they say Cu. Organic acids say Cu. It's that they have on them a carbon double bonded to an oxygen and single bonded to an OH, COOH, Cu. But organic acids like vinegar always have that. In aspirin, there's a lot of other natural organic acids, and they are going to have that Cu on them. And if you want to know more about that, you'll learn a lot more about that when you take organic chemistry, or you would learn more in Chem 2 or AP Chem. So another definition of acids is the Bronsted Lowry, and they said that an acid is any hydrogen donor, anything that gives off an acid, and a base is a hydrogen acceptor, anything that can take and accept that that hydrogen is a base. The reason why they had to come up with a new definition is ammonia. Ammonia is a base, and it does not have OH in it. It doesn't have hydroxide. So there had to be more to bases than them being able to donate or to break apart into that hydroxide ion. And there are other definitions of acids and bases. So measuring pH, we do that with an indicator. They turn colors. Also, we can use a pH meter. I have one. Mine is not real good. I got it for free. The teacher that I took her place when I used to teach at a different county, she gave me her pH meter. She had won in a contest. It doesn't work real good. There's a reason why she gave it to me, I think. I mean, I like it because at least I can show kids, look, this is a pH meter. You stick it in and it reads the pH. The strength of acids and bases is how much they disassociate. Strong acids dissociate completely. Hydrochloric acid, the hydrogen and the chlorides come completely apart in water. Weaker acids don't come completely apart. Not as many of them disassociate. Same thing with bases. Strong bases disassociate completely. Weak bases, not as many of them disassociate. And there is math you can do to figure this out, which is beyond the scope of this class, but it's in your book, so you're welcome to take a look at it. If you want to know how to do the math, look up Peterson's Science. Mr. Peterson has plenty of videos on this where he'll walk you through it. All right, so that is it for our chapter 19, and I'm actually going to just flip to 20 and explain to you once again that if you mix an acid and a base, you get salt and water. And what I want to add to 20 that I want you to look at more than that is I want you to do the lab. I want you to do the lab on page 571 where you are going to do a neutralization reaction where you're going to mix vinegar and baking soda baking soda volcano, and also some commercial antacid tablets. So that was the main thing I want to do. I want you to look in your book at what a titration is. We're not going to do that. I'm not even going to do that with my public school kids until they get into AP Chem. They can do it there. But college really likes those titrations. Let's see. And the rest of that is all more honors level. So we're not going to be doing it. I just wanted you to do the lab out of chapter 20. So that's what we're going to do. That's it for our class. Like, share, subscribe. Come back and learn physics with me if you want. That would be the next class for you. And remember, science is great. And I hope you enjoyed chemistry. See you next time.